Hi to everybody watching this video. I just kind of wanted to put this together to kind of show you a different perspective on time dilation formulas and how you might be able to easily grasp how moving through space changes how much we're moving through time. A lot of this is just a different perspective in how you view things, but really the main piece is, and you'll see this at the end of the video, you are always moving at the speed of light. It's kind of just a different it's taking into account your vector through time and space. And those two together, you will see, will always show that you're moving at the speed of light. But let me get to that. So right now, you are looking at a time dilation graph. And this is how you would typically see it if you looked up Google images for time dilation. What you see here is just 1 over the square root of 1 minus our velocity squared. Velocity is being depicted on the x-axis here, over the speed of light squared. So we have point B here showing, okay, if you were observing an object going at this speed, sorry, there's no commas, so it's kind of hard to read. If you're observing an object going this speed, it will, for every 1.17 seconds you experience, it will experience 1 second. And so it's just saying, yep, time's dilating as you get faster and faster. And so you could see it kind of explodes towards the end here as we really get close to the speed of light. But even here, so 296, 299, we're very close to the speed of light at this point. And you're experiencing 6.35 seconds for the object only experiencing 1 second. So it's not a huge change until you really get up to those very high speeds. But as you can see by the graph, it really gets up there pretty quick. So this is one way that you'll see it online depicted. The other way, I'm going to take this 1 out of the numerator, and it really just flips the chart over and says, okay, I find this easier to read. It says for that speed, the object you are viewing going at that speed is going at 16% of the time that you're going at per second. So for every second, it's experiencing 16% of that second through time. But really, this is getting us closer to where I think you'll get an easier understanding of what I was saying earlier, but you really don't get a view of that until you can view it in the Planck units. So we're going to change this variable c to 1 to kind of normalize it, which is what the Planck units are doing. So I'm going to flip to this next tab where I already have that done. So now we have 1 minus x squared over c squared. C squared is now equal to 1, or c is now equal to 1. So I made a little bit more color on what's going on here, but you see the chart turns into a quarter circle. So no matter where you are on this point, you are always the same distance from the origin at point B. So point B is where the addition of vector A and vector D goes to, and it's always equal to the speed of light. So really this is saying, let's see, at point B, when you are going 0.6% the speed, or 60% of the speed of light, you are going to be seeing time dilation effects of 80%. So for every, that's observing an object going 60% of the speed of light, it'll be going 80% of the speed through time that you would be going through as the observer. But yeah, you could see here very easily, just as you approach the speed of light, so now you're going through space at very close to the speed of light. A over here, you're going through time a lot slower. I think this is very telling, and here's my favorite part. If you are going, the flip side of this is if you get close to rest, or let's say that this is you at resting speed, 0, you are going through time at the speed of light, or the object you are observing is going through time at the speed of light. But it's really these two vectors adding together, always maintaining point B at the speed of light. So some of it's through space, some of it's through time, but regardless, you are always going the speed of light. I think this is pretty neat, and you could see it changes just as the circle changes. So very neat. helps me really understand how we're going through time. You could almost picture it as a throttle. Okay, throttling up in speed, throttling down in time by the same amount. So very neat. Let me know what you think in the comments if this helps you understand anything related to this. It also relates to Lorentz contraction. You could be looking at it the same way. So let me know if this helped you understand time dilation a little bit better. It helped me. Thank you. Leave comments. Bye.